Okay, so I will continue checking homework in a little bit, but for right now, let's get started together as a group. So today is our third class, last day of January. We're going to cover linear models, lots of stuff about linear equations that I'm assuming a bunch of it you actually know already. So hopefully a bunch of this will be a review, but that's where we are, and that will be the end of our first week. Someone had asked about when the first quest is. It's coming up February 10th, which I think is going to be a week from this coming Monday. Okay, questions on the calendar? Okay, so a couple of logistical things before we dive into the math. First of all, the Math Studio bookmarks were just printed yesterday, so grab one of these yellow bookmarks from your table. They tell you exactly when the Math Studio is covered by a faculty member. It's not every hour, but it's a bunch of hours. So if you make sure you go when there are people there, you get all your questions answered. So I was over there this morning. You can see that I'm there on Friday mornings right before our class. And there's somebody there before our class every morning, and there's somebody there right after our class. So if you have a free period after, or if you can get here a little bit early and come in and work with your classmates beforehand, you get all your homework questions answered. And again, it's a great resource. I saw, I think, about 4 of you guys over there this morning, and it would be great if we had even more. All right. So the next thing I wanted to talk about was the syllabus. Part of your assignment on the first night was to ask me questions about the syllabus, tell me what you wish weren't in the syllabus, and to tell me a little bit about yourself as a math student. And so what I wanted to do was respond to some of the questions that people had. And I thought I would just respond to everybody in case, because I think there's some good information here. So we're going to look at a few of these today and then the rest of the next class. So the first question that somebody asked was, why can't you make up a test or a quiz? That's one of the policies in the syllabus. So first, I'm just a big meanie, and that's why I won't let you make up a test or quiz. Also, writing them takes a lot of time. I don't just have extra ones sitting around. So like making another one for you would take like an hour plus. But more important than that, I want to be fair, and giving somebody an extra day or two to study for a quest or a test doesn't seem fair to everybody else in terms of study time. However, if there's an emergency, of course, I will work with you. But I'm the one that's going to decide how urgent and whether or not you were able to make it here. And the more lead time you can give me, the stronger your case. If you contact me after the test, that's not going to bode very well for you in most cases. But if you know beforehand, even if it's an hour beforehand, hey Ian, I got a flat tire. I'm going to try to make it, but I can't. It might be something I can work with. All right. So whatever lead time you can give me, give it to me. Okay, somebody noticed that in the syllabus, in the catalog description of this course, it says that this course does not fulfill degree requirements, and it's true. So let's talk about, we'll just take a quick peek at this math flowchart. I can make it a little bigger. Okay, so many of you came from Math 095, Introductory Algebra, and from there you actually have 4 different places that you could have gone to as another math course. So you are here in Intermediate Algebra. The fact that there is a 0 in the front of this course number means that it does not fulfill the math requirement for any of the degrees or certificates that we offer at GCC. In order to fulfill the math requirement for the general liberal arts degree, which is our most popular major, you need a course number that starts with a 1. So I'm assuming that many of you are headed to Math 107 next semester, which is college algebra. And if you are in a major that heads you in any kind of mathematical or sciencey direction, this is definitely the track for you. The college algebra course leads to pre-calculus, which leads to calculus and beyond. So that course is the long one, and it's designed for students in engineering and science and math, technical fields. But there's also a course called Mathematical Problem Solving, which all of you are eligible to be in right now this semester. And if you want to make a change, then we could make that change today. And I think today is the last day to add. So if you aren't sure, maybe come find me right after class and I can talk to you about it. You can fulfill the degree requirements of our liberal arts degree this semester by taking Math 117, as opposed to next semester after you finish this course, right? Not trying to discourage any of you from staying, but I just want to be clear about what the numbers mean and about that whole degree requirements thing. So see me right after class if any of that, if you have questions about any of that. Like I said, there's a time-sensitive nature here because today is the last day add a class. Will there be extra credit or bonus questions on the quests or the tests? No, but thanks for asking. All right, when I have trouble on homework and I don't have the work done right on a problem, can I fit it and get full credit? I wasn't 100% sure of what this fit it part meant, but I assumed it had something to do with, well, you know, if I finish the homework, but then I get help either in the studio or in class or some other time besides when I'm actually doing the homework, yes, you'll absolutely get full credit. I encourage you to check your homework answers in the answer key in the back. Ask somebody, a classmate, me, the math studio, a peer tutor, for help on any questions you got wrong. All right? I grade your homework on completeness, but I want you to check for correctness and get help for anything that you don't know how to do. Any questions on any of that stuff? Okay, so there are a few more things in here. We'll look at the rest of this document on Monday, but I just wanted to address some of the questions that folks had about the syllabus. Okay, so I think we're ready to start. So let's go to page 14 in the packet, and we'll go up here to number 1. And we're going to blitz through some vocabulary here. There's a lot of, the group activity is quite long, so I want to make sure we have time to get there. Can we start in the middle? Lauren, number 1. Thank you. Brittany, number 2 on page 14. Okay, thank you. So we're going to start this whole problem by assuming that we have an individual who works X hours at a salary of $7.50 per hour. So let's begin here with part A. It says fill in the table of values showing the wages, which we'll call W in dollars, earned for the number of hours worked X. So if the person works 0 hours, how much money will they make? 0. Okay, that seems fair. If they work 1 hour, what is their hourly wage? $7.50. So they'll have $7.50 to their name minus taxes. If they work 2 hours, $15. That's easy enough. Okay, even if we can't do the calculation immediately in our heads, what do we need to calculate to find the salary here for 6 hours? 750 times 6. Everyone agree? That's what we need to find. Okay, is that 45? All right, so that's 45. And then 10 hours should be easy enough to do. $75. Okay? All right, so let's take a look at part B. We'll go to Victor. Okay, so let's take a look. Going from 0 hours to 1 hour, how much did this person gain? $7.50. Going from 1 hour to 2 hours, how much did they gain? $7.50, right? 15 minus the $7.50. And that's the constant. That's the rate of change. Each additional hour, they gain another $7.50. It would be a little bit different if we had some kind of overtime pay where maybe you make time and a half. That's not this. This is a flat rate of $7.50 an hour, regardless of whether you work 1 hour or 100 hours. And that's the constant rate of change. So $7.50 is the answer to this question. Does this hourly rate change or stay constant? It stays constant. Okay, let's go back to Craig for each. Thank you. All right, moving on to part C. It says write an equation for W in terms of X. Now this is vocabulary that you saw if you came out of this Math 095 class. That exact phrasing, an equation for blank in terms of blank. So just to remind you, in case you've forgotten, an equation for W in terms of X means the equation is going to have this form. W equals. Whatever letter is there right after the word for is the one that's by itself. The letter that's there at the end is the one that's buried inside of some other numbers. So in this case, an equation for W in terms of X, W equals, what's the general formula here? 750X. We agree? In that chart up above, we took 750 and multiplied it by the number of hours. That's X. Okay, part D says graph the equation. All right, let's graph this guy by plotting some points. So for example, you can plot the point 0, 0. So put a dot right there. What's the name of that point? That's the origin. And then you can plot the point 1, 750. And go ahead and plot, I guess we have 5 different points we can plot, each of them from the table. And we should notice that all 5 of these points appear to be on the same line. And so we'll connect the dots with a straight line. I'm not a big stickler for putting arrows on things, but I'll just put one. And that's the graph. And the fact that this is a straight line matches up with the idea that there is this constant rate of change. If the person started making time and a half, when does time and a half usually start? Like 40 hours in maybe? So I don't have, my graph doesn't go out far enough. Let's say that this is a very generous time and a half that begins after 10 hours. And if after 10 hours we started making not $7.50 an hour, but say $9 an hour because we're working overtime, any ideas what would happen at this point right here? It would start going up steeper. You'd have maybe a different line because you're making now $9 an hour instead of $7.50. Right? But because that doesn't happen here, because it's just a constant rate of change, it's a straight line. Okay, part E is more vocabulary. I think we're back to Tim. E. Keep going, please. Can you put that away? That away. Okay, so dependent and independent, we need to know which one is which. This is a little silly mnemonic device I came up with, so I'm assuming most of you know Johnny Depp from Pirates of the Caribbean, and if he's out there by an island on himself, that's the dependent or dependent variable. So the one that's by itself is the dependent variable. So in this equation, which one is the dependent variable? W. That one right there is the dependent one, and then by default, the other guy is the independent one. Okay, different problem, but some similarities. Let's move on to Yurka for 3. Okay, thank you. Let's pause there. So we've got these 2 equations that both represent the same situation. T is the tuition and fees, X is the number of credits. So this equation is the one that's a little bit more natural for me. It says the tuition is 121 times the number of credits. So what does that mean? The tuition is 121 times the number of credits. What's going on with, louder for us?
They charge you $121 per credit.
That's it. Tuition is 121 times the number of credits. You are charged $121 per credit. Equivalently, if you decided to, say, divide both sides by 121, then you'd have this equation right here, and it would tell you that the number of credits is your tuition divided by 121. So if I tell you my tuition bill is $363, and I want to know how many credits that means, you just plug 363 in for that T right there, and we get 3 credits. And then going the other direction, if a student is taking 5 credits, and you want to know how much the charge is, probably want to go to this equation. So just plug a 5 right there. 121 times 5 gives us the bill of $605. Okay, let's go to part A, and we'll go back to Karen. All right, and pretty much you could just circle the right one if you want to, but only one of them is in the form T in terms of X. First one or second one? Second one. T in terms of means T is by itself. Equation for T. Next page. Okay, lots of blanks. I think even one of the blanks might be part of a hole punch in your page. I'm not sure. So since blank is by itself, okay, which letter is by itself in the equation that we circled? T. Since T is by itself, then that same letter, T, is it the dependent or is it the independent variable? Is dependent, the one that's by itself. It's like Johnny Depp on the island. This is the dependent variable. Dependent. And then in the next blank, it's the other letter. What was the other letter? X. And what kind of variable is X? Independent. So just some vocabulary. All right, we'll move up to Mariah for 4. Okay, so we've got this vocabulary phrase here, ax plus by equals c, apparently is called general form. To be honest, I'm not going to test you on that phrase because I can never remember whether general form is that or with a 0 on one side. And frankly, general form is not a form that we're going to use very often. But let's just make sure we can graph it in case we see it. 3x plus 2y equals 12. We're going to fill in this table with 4 solutions to that equation, and then we're going to plot 4 points. Okay, let's go to Megan. Megan, pick your favorite number for x. Any number you want. 4. Great. We'll go around the table here. Ryan, the 3. Okay, and now I'm going to pick a couple of favorite y values. 6 for y and one more y value. 8. Great. So what we need to do is fill in the other blanks. If we picked a random x, we got to find the corresponding y. And if we picked a y, we got to find the x. I'll do one here, and then you guys can chat with each other about the rest. For example, if x is 4, right here, then we're going to do 3 times 4, that's the x, plus 2 times, I don't know, is supposed to be 12. Everybody see it? Just change the x into the number that we picked. And then we got some algebra to do. 12 plus 2y equals 12. Trying to get the y by itself. What number do we move first? The 12 has to go over to the other side, so subtract 12 from both sides. Minus 12 minus 12. Conveniently, that becomes 0. We did that on purpose. And then finally, to solve for y, divide by 2. How much is 0 divided by 2? 0. So after all that work, we get the y value at 0. So that means the point 4, 0 is definitely on the graph of this equation. With your neighbors, fill in the rest of this table. So I filled in my 4 points up here. It's okay if you didn't quite get them all done, but whichever ones you have there, we're going to plot. So let's plot the point 4, 0. So 4 zeros out there, and then go ahead and plot the other 3 points that I've got. You can just copy them, even if you didn't get to them. At negative 1.331, you'll have to just ballpark. And what do we notice about all 4 points? Sure looks like they're on a line. Okay, so we'll connect the dots. And we'll do a better job than that. So let's try again. Good enough. Questions on that one? All right. Now, the folks at this front table here happen to pick some points that are given a special name. We had the 0.4 comma 0, and then we had the 0.0 comma 6. And we had a 0 in each of those coordinates. And those guys have names. In fact, you can see them out here. There's 40, there's 06. Anybody know the names of those 2 points? Those are the intercepts, right? X-intercept is 40, Y-intercept is 06. So let's just read through here. So we'll start with 6. Where are we now? I think we're over to Boo, 6. Okay, so it's not a big deal, but this table only had 4 rows in it. It could have 100 rows, or it could have many, many points that satisfy the equation. That red line is supposed to represent all of them, every single one of the infinitely many things that we could put in the table. Okay, moving on to 7. I think we're here to Alan. Okay, so it happens that we kind of randomly, but maybe not so randomly, ended up plotting those 2 points. So it's a yes, because I see them in the table. But even if I didn't see them in the table, I could look at the graph and say, oh, it looks like we're right around those points. So it happens they're in the table. I'm going to write here, they're on the graph, just in case we didn't happen to plot them specifically. They're on the graph. Okay, and we'll move on to Abby for the first since. Keep going. Okay, so then it says plot and label these 2 points. Well, we've already plotted them because we happen to pick them in our table, but we can label them. So this is 40, and this is 06, and that's the x-intercept, and that's the y-intercept. And it turns out that finding those points is generally a really, really easy thing to do, and it's often an easy way to graph a line. So we're going to try to graph the line down below by just finding intercepts. So let's give that a shot down here. Number 8, Alexa. Okay, thank you. So we'll make a table just like the one that's above. And then we're going to pick the really, really easy numbers to plug in. And the easiest number to plug in is a 0. So I'm going to let x equal 0 and find the y. And then separately, I'm going to let y equal 0 and find the x. So let's do the first one first. If we let x equal 0, this equation becomes 0 over 4 minus something over 6 is supposed to equal 1. So just like we did before, copy the entire equation, but just change that one variable to the number that we picked. But we picked an easy number, 0. How much is 0 divided by 4? 0. So this is really 0 minus y over 6. And 0 doesn't do anything, so that's just minus y over 6. You can do algebra if you want. Maybe you can just look at that equation. How much is y? -6. We need a -6 to go up there to make a 1. So y is equal to -6, and that goes right there. And then you can plot the point 0, -6. It's quick. And then play the same game, but change the y to 0. So we'll do that here. X over 4 minus 0 over 6 is 1. Zero over 6 doesn't contribute anything, so I don't write it. How much is x? X is 4. And then the other point is 4, 0. And then we can plot these 2 points, and then I think we're just about done. 0, -6 is down there, and then 4, 0. And as long as I'm comfortable saying, oh, that's the equation of a line, then 2 points is all I need. I don't need 4 points or 8 or anything like that. Just connect the dots on 2 points. Questions on the intercept method? It's a pretty good way to graph a lot of lines. And I'll just say one other thing, and then you guys will work in your groups. We will spend plenty of time talking about this version of the equation of a line, y equals mx plus b. We probably won't use this one as much, but you might have seen it in some other class. But the fact is, a lot of students feel compelled. If you have the equation of a line and you want to graph it, a lot of students feel compelled to put it in this form. And sometimes there are really good reasons for putting a line in that form. But solving for y in this equation right here is quite a bit of work, and there's a lot of ways to make mistakes in doing so. If I say, hey, you got to put it in this form, then okay, you got to put it in that form. But if you're just trying to draw the line, do not feel obligated to just always solve for y. Don't need to. This is the easiest way to graph the line. All right, so we'll talk about mx plus b soon enough. All right, on the next page, there's a problem about balloons. And then on the page after that, there's another word problem that you're going to work through. I decided yesterday to make both of these part of the group activity. So technically the group activity starts like 2 pages from here, but we're going to start it here. So what I want you guys to do is work through these with your groups. Raise a flag if I can help. Now, because it wasn't part of the group activity when I printed this document, there's no answer key in the packet, but I typed one up yesterday and I will project it here in just a minute or two. So start on number 9. You can check your answers up on the smartboard soon, and then go all the way through that activity 2 pages away. Oh, one other quick announcement. Sorry. There's an unusual piece to the homework for tonight. It's not due until the beginning of class 5, which is not next class, but Wednesday. I'm giving you a little extra time on this one because it's an unusual assignment. It involves downloading a free piece of software and then using it to do this thing down here. It gives you the explanation for how to download the software, but I just want to give you a heads up that there's this unusual piece to the homework. If you don't have your own computer, it's no problem. This software already exists on all the computers in the studio, so you can just go over there right after or before class and do the assignment. It's already there. But I want you to know that there's this strange part of the homework. Okay, that's it.